Okay, happy Turkey Day week. We are almost there. Today is quadratic problem solving day 2. So it just kind of builds upon the stuff we did the other day. You don't necessarily have to be an expert at that to be able to do this. It just might be beneficial to be able to kind of wrap our heads around it. First thing is you might want to write down these formulas. The one in height, or the one in feet, the one in meters for both of them. The drop ones, if we're just dropping something, we don't have an initial velocity. So this v sub naught, this v sub 0, that's all that is there. That's initial height, okay? This v sub naught, that's initial velocity. So we'll get to a couple problems like that here in a second. But all you got to know is h sub o, right there, that's subscript, is initial height. And v sub o, v sub naught, is the initial velocity. I'm gonna skip 1 and 2 because we're gonna do that anyway. We're just dropping stuff, and so all you're literally doing is plugging 1 in for t and 3 in for t. I think that's pretty self-explanatory. So we're gonna go ahead and jump to number 2 if that's okay with y'all. First part we're gonna do is write an equation. So writing this equation, we're gonna have h of t. So h of t equals, and my pen's kind of thick, so I'm going to try and squash it down a little bit. See if it's any better. That's a little better. Okay, so it's always, since we're dealing with feet, it's negative. Okay. Sorry about that. Negative 16t squared plus our initial velocity, so plus 200t plus 30. Okay, that's our equation. Let's go ahead and put this in our calculator. So negative 16, we're going to use x instead of t, plus, was that 200? X plus 30, okay? I'm going to go to zoom 6, I'm going to set my table back to, or our window back to everyone else's, so we all get the same cruddy picture. Just making sure I put it in right. Cool, we did that. So I can't see it, so I'm going to go to my window, I'm going to play around a little bit. Now, x is my time, so I don't really need negative 10 seconds. I'm going to have negative 2 just for the heck of it. My maximum, I'm going to try 20 there. 20 seconds sounds like good. Y minimum, I can't have negative height, so I'm going to put negative 2 again. And since I've done this problem before, I'm going to go ahead and tell you that Y max needs to be around 800. So when I graph that, I should hopefully get to see my entire arc, my parabola. There we go. So go ahead and rough sketch that, and then our window, if you want to pause it, that's going to be your other part. Okay, so rough sketch, boom, and then your X-Men, all that stuff, that's where this comes into play. Okay, so that's that, and then we're going to answer a number of questions about this. And this is pretty much the entire lesson, okay? What does the y-intercept of the graph mean? Well, the y-intercept of the graph, where it starts is the, that's the height of my launch pad. So height of launch pad. Alrighty, greatest height. Well, greatest height, if I want to find that, I'm going to do second trace. I'm going to go to maximum. And then my maximum is my greatest height. So I'm going to go to the left of it because this is left bound. I'm going to press enter. Right bound. Come on. Enter. Enter one more time. And my height is 655 feet. So height, 655 feet. Greatest, another name for the greatest height, we just said that was my maximum. Time, our time was 6.25 seconds. Wants to know at what time is the rocket 500 feet. So this one, we got to go under a Y2, and we're going to put in 500. I'm going to see where they intersect. I got a red and blue line. You probably just got 2 black lines. So second trace, intersect. I want to find out where these 2 intersect. So enter, enter. And I'm going to arrow over to where they intersect on the left. If you don't do this, you're probably going to get 2 of the same answer. That's not very beneficial. So 3.14, I guess. And then I want to do this again. I want to come up with the other time. First curve, yes. Second curve, yes. And then I got to arrow over to the right. Just as far as as long as you're more than halfway across there, it should work just fine. 9.36. All right. When did the rocket hit the ground? Well, rocket hits the ground. That's also called a zero. And so I need to be sure I'm to the left of it. It hits down here, so I'm to the left of it already. And then I want to be to the right of it. Looks like I'm on the right. Good. I press enter one more time. Where does it hit? It hits at 12.6. We'll round that up. 12.65 seconds. By the way, this was seconds as well. All right, now that's pretty much it. So let's kind of run back over that again. Greatest height, this is the maximum. That's what we did in the calculator. Time the rocket hits, is it maximum height? Once again, that was its maximum. Times, we put that in our y2, and we did the intersect. So I'm going to write y2 int, and then hit the ground. That was my 0. Okay? That's pretty much all I wanted to go over. Number three is pretty self-explanatory. We can do that if you want. We're going to write the equation once it meters. So why do I keep picking that? Sorry, y equals negative 4.9 t squared plus 13t. Then it wants to know, 2 seconds after he jumps, how high is it? So go ahead and put negative 4.9, and you can just put 2 in. You don't have to put this in the y equals. Just go into our home screen of our calculator, which I might still have it in there. Boom, there you go. So our height is 6.4 meters. Hopefully that makes sense. I think it does. 4 is the same type of problem. 5 is kind of a sad squirrel problem. Probably don't need to do that. 6 works the same way. We can do that one if you want. So go ahead and put that into your y1. The hardest thing is coming up the window. If you want to keep my window the same for all of them, that's probably safe. Just not sure the y max is 800, so it's kind of big. So we got negative 16. Be sure you do it squared here. And then plus 128. So graphing, whoa, if you don't do a negative 16, that'll get you. Come on. Or if you don't do a plus either. Give me a plus sign right there. Boom, there we go. Cool, so we got that. So we want to know, when will the object reach a height of 192 feet? So that means we're going to go under y2. We're going to put 192 in. I'm going to second table, and I think this one's whole numbers, so we can actually see. Yeah, look at there. It'd probably be wise to double check, just the table real quick. So at 2 and at 6 seconds. Oops, this is not what I wanted to do. Sorry. Nope, still screwing up. One more time. There we go. So at 2 and 6 seconds. When will it reach the ground? If I go back here, looks like at 0 seconds. Duh. And at 8 seconds. See, 8, 0. It'd be wise to go and double check with the graph, but believe me, it is 8 seconds. So 8 seconds. When will it reach the maximum height? Pretty sure it's 4. Come on. One more. Yeah, 4. 256. What is the maximum height? 256. We graph it. Domain is from 0 to 8 seconds when it reaches the ground, and my range is from 0 to my highest point, 256. I know it's kind of quick, but that was pretty much it. Go back, watch my keystrokes again. Wish you the best of luck. See you later.